In this demonstration, we're working with a patient where we suspect the refractive error has increased. Patients taking minus power over the contact lens. And then there's also some residual cylinder in the post-treatment refraction. And the post-treatment topography shows some incomplete closure of the reverse zone. So the first thing we'll do is make adjustments to the base curve of the lens. And I'm going to alter the refractive error by a diopter. And we'll see that our power has dropped into negative, meaning our base curve is actually way too steep for this amount of myopia. So we'll just go into slightly faster mode, and in 100% we'll flatten this base curve out. And then around a 1.5 should probably be enough for myopia control cases. Some folks are going a little bit more just to get a little bit of overcorrection. But if that's not your target here, then about a diopter and a half in power should be sufficient. Anytime you change the base curve and you're not in RSIM design mode, it's a good idea to check the different meridians. For example, we're here off by an eighth of a diopter or so. And if we click around, we can see there's some meridians where it's not very uniform, almost a quarter difference here. So we'll just go into 25% mode and we'll touch these up individually. And now we have our flatter base curve, which is pretty uniform all the way around. Go back to 100% mode. And then on the post-treatment topography, we could see that the reverse curve zone was kind of incomplete. This is the left eye superotemporal. And so that could be either that there is not enough sag at the lens here in this area, or it could also be that there's too much sag in the lens peripherally, and it's preventing the back edge of the reverse curve from landing on the cornea. Based on the video that was submitted, I think the edge profile is okay, or the sag at the edge is okay. So we just want to increase sag here at the back edge of the reverse curve. So even though it's only one quadrant, we're in a GSIM design, and I think it's okay to make this change all the way around. So we'll just look at our starting point. We're at 766 and 1889, and we got a target about a 10 to 12 micron increase here at the IC point, the blue control point. So let's say we do 10, we'll end up with a target of 776. 1889, we don't want that to change, and so we will have to make an adjustment to compensate for that afterwards, but we'll make this change first. and we're at 1776. So making this change not only increased the sagittal depth of the lens at this point, but all the way out into the periphery as well. So we started at 1889 and we've gained about 14 microns out here, and we don't want that. We want the sag at the edge of the lens to stay where it was before, so we'll need to decrease that. Click up to decrease sag. And now we have our original sag value again, but with an IC sag that's 10 microns greater than the prior lens. So flatter base curve on this lens and slightly taller at the back edge of the reverse curve only with no change at the edge should help get this patient seeing a little bit better.